Hello there, welcome to Ethio-Hahu tutorial. I'm Getachew, and today I'm going to do questions on different parts of kinematics of particles, dynamics of particles, and simple harmonic motion. The first exercise: a car moves on a straight road with a velocity of 30 km per hour when the brake is applied. If the car stops in 20 seconds after the brake is applied, how far does it go before coming to a stop? Solution: let's have first given the initial velocity of the car is v0 is equal to 36 km per hour, and the time it takes to stop is 20 seconds. T is equal to 20 seconds, and the final speed of the car is 0. What is the distance traveled by the car before coming to a stop? Because here the car is moving with v0 36 km per hour, and then it comes to a stop. V final is equal to 0 while moving this much distance, delta S. This is what we are going to find. First, we need to convert this kilometer per hour into meter per second. One is multiplicative identity, therefore v0 is equal to 36 km per hour. If we multiply this by 1, does not change the value. Therefore, 1 hour means 3600 seconds. 1 kilometer is 10 to the power of 3 meter. This one is 1 still, because 1 hour is 3600 seconds, and 1 kilometer is 10 to the power of 3 meter. Here kilometer goes with kilometer, hour goes with hour. By 36 1, by 36 100, 10 to the power of 3 divided by 100 means 1000 divided by 100 is 10 meter per second. This is the initial speed. The final speed is 0. Time is 20 seconds, and we need to find distance. Therefore, we can find the distance in different ways. One, by finding the average velocity. V average is equal to V initial plus V final divided by 2, assuming that the acceleration is uniform. V0 is 10 meters per second plus V final is 0 divided by 2. 10 by 2 is 5 meters per second. V average is 5 meters per second. Therefore, distance is equal to V average times time. V average is 5 meters per second times time is 20 seconds. Second goes with second. 5 times 20, 100 meter. Or in other ways, first let's find acceleration. Acceleration is equal to V final minus V initial divided by time. V final is 0 minus V initial is 10 meter per second divided by T is 20 seconds. This is equal to minus 1 over 2 meter per second square. The negative sign shows that the car is decelerating. Therefore, displacement is equal to V0 times T plus half AT square. V0 is 10, T is 20 plus 1 over 2. Acceleration is minus 1 over 2 times time is 20 square. 10 times 20, 200 meter minus 1 over 4 times 20 square is 400 meter. By 4, 100. 200 minus 100 is 100 meter. The second exercise: a box rests on the back of a truck. The coefficient of friction between the box and the surface is 0.2. What is the maximum acceleration the truck can have before the box slides? let's have given the coefficient of friction is 0.2. Let's have free body diagram. Here's the track. On the track we have a box. This box, and this is track. When the track accelerates with an acceleration a, the box tends to slide to the left because the box rests on the track. But the box as well as the track will have the same acceleration. The box has the same acceleration as that of the track because the box is moving with the track. Due to that, the acceleration of the box is the same as the acceleration of the track. When the track accelerates to the right, the box starts to slide to the left. When the box starts to slide to the left, the friction force between the box and the track is to the right. This is the frictional force acting on the block or the box. Therefore, on the box, we have normal force acting on the box, gravitational force, and frictional force. There are three forces acting on the box. If we are able to find the acceleration of the box, then the acceleration of the box is the same as the acceleration of the track because the box is moving with the track. Let's write free body diagram for the box. Here we have normal force, gravitational force, and frictional force acting on the box because the box starts to slide to the left. That's why the frictional force is to the right. Normal force is the same as gravitational force, but the frictional force is the only net force acting on the box. Therefore, the net force acting on the box is equal to mass times acceleration. But the net force acting on the box is frictional force. This is equal to mass times acceleration. This implies frictional force is by definition coefficient of friction times normal force. This is equal to mass times acceleration. Again, this implies coefficient of friction times normal force is mass times gravity, m times g, which is equal to mass times acceleration. Here m cancels and we are left with acceleration is equal to coefficient of friction times g. Coefficient of friction is 0.2 times g is 10 meter per second square. This is equal to 2 meter per second square. This is the acceleration of the box. Since the box is moving together with the track has this much acceleration. Therefore, the acceleration of the track is the same as the acceleration of box, that is 2 meter per second square. The third exercise, a shooter aims his gun and shoots directly at a target placed 400 meters horizontally away from him. By how much will he miss his target if the muzzle velocity of the bullet is 400 meters per second? Here we have a shooter and a target. This is a target. A shooter aims to shoot a bullet to a target that is 400 meters away, or delta x. But this is a kind of horizontal projectile. This bullet moves in this direction and reaches this point. Therefore, first, the time required to move this horizontal distance is the same as the time taken by the bullet to fall this vertical height. This is the missing height because the target is this one. When a shooter aims to hit this target, but due to the presence of gravitational force, the vertical component of the velocity of the projectile is affected and it accelerates downward. Therefore, the vertical velocity increases, whereas the horizontal velocity remains the same. The horizontal velocity of the bullet is 400 meter per second, but the vertical velocity of the bullet is 0. Initially, the bullet is moving horizontally from x component of motion. Delta x is equal to v naught x times time, because the horizontal component of the velocity of the projectile remains the same. In the absence of air resistance, the only net force acting on the projectile is gravitational force at every point. Horizontally, we don't have net force. Due to the absence of this net force, the horizontal component of the velocity of the projectile is unchanged. That's why v naught x is equal to simply vx times t, where vx is the velocity of the projectile at any instant of time. From this, the time required by the projectile to move this horizontal distance 400 meter is delta x divided by v naught x. Delta x is 400 meter divided by v naught x is 400 meter per second. 400 goes with 400, meter goes with meter, second goes to the numerator part. This is equal to 1 second. Therefore, the time required by the bullet to move this horizontal distance is 1 second. With this 1 second, we can find the vertical height that the bullet misses the target. This can be obtained from the vertical motion, from the vertical component. H is equal to v naught y times t plus half gt square. v naught y is 0. This is 0. H is equal to half times g is 10 meter per second square times t is 1 second square. This is equal to by 2 1 by 2 5 meter second square goes with second square. We are left with 5 meters. Therefore, h is equal to 5 meter. The fourth exercise, a 1 kilogram object starts from rest at the top of an inclined plane down the incline of height 4 meter. If it reaches the bottom of the incline with a speed of 6 meters per second, what percentage of its total energy at the top of the incline is lost as a result of friction? Here, given that mass is equal to 1 kilogram, starts from rest, the initial velocity 0, at the top of an inclined plane and slash down the incline of height, h is equal to 4 meter. This is the incline, this is h, 4 meter. This is the object that slides down this inclined plane. When it reaches the bottom of the incline, the final velocity is 6 meter per second. When the block reaches this, it has a speed of 6 meter per second. Here v naught is equal to 0. Therefore, let's consider this point is A and this point is B. In general, work done by non-conservative force is equal to change in mechanical energy. In the absence of non-dissipative force, non-conservative force, mechanical energy is conserved. But if there are forces other than the conservative forces, mechanical energy is not conserved. To see that, let's consider mechanical energy at point A and mechanical energy at point B. Mechanical energy at point A is simply kinetic energy at point A plus gravitational potential energy at point A. When we say kinetic energy at point A, translational kinetic energy, this is 0 because the speed at point A is 0. Therefore, half times m times v naught square is 0 plus gravitational potential energy is m times g times h. This is 0. This is equal to m is 1 kilogram, g is 10 meter per second square times h is 4 meter. 1 times 10 times 4, 40. Mechanical energy at A is 40 joule. Kilogram meter per second square is Newton. Newton meter is joule. Similarly, mechanical energy at point B is simply kinetic energy at point B plus gravitational potential energy at point B. This is our reference point. At the reference point, H is 0. Therefore, gravitational potential energy at point B is 0. We have only kinetic energy. Half times M is 1 kilogram times V is 6 meter per second, the whole square. This is equal to 36 divided by 2, 18 joule. Kilogram meter per second square times meter is joule. Since mechanical energy at point A and mechanical energy at point B are different, mechanical energy is not conserved. Therefore, from conservation of mechanical energy, work done by friction is equal to change in mechanical energy. This is equal to mechanical energy at point B minus mechanical energy at point A. This implies work done by friction is equal to mechanical energy at point B is 18 joule minus mechanical energy at point A is 40 joule. This is equal to minus 22 joule. Here the negative sign shows that work is done by friction, and this is loss in mechanical energy of the system. But the question is, what percentage of the total energy is lost as a result of friction? To find the percentage loss of the total energy is equal to work done by friction divided by total energy. The total energy is 40 joule. This is 22 joule divided by 40 joule. Joule goes with joule. 22 divided by 40 is equal to 55%. The next exercise 5. In a thermodynamic process, 1.5 times 10 to the power of 5 joule of heat is added to an ideal gas to keep the pressure constant at 2 times 10 to the power of 5 Pascal, while the volume increases from 6.3 cubic meter to 7.1 cubic meter. What is the change in internal energy of the gas? This is a process of constant pressure, isobaric process. Given that 1.5 times 10 to the power of 5 joule of heat is added to the system, delta Q is equal to 1.5 times 10 to the power of 5 joule is added to the system. If heat is added to the system, it is positive from sign convention. And the pressure is 2 times 10 to the power of 5 Pascal. While the volume increases, V1 is equal to 6.3 cubic meter, and V2, the final volume, is 7.1 cubic meter. What is the change in internal energy of the gas? Change in internal energy of the gas is the required quantity. But here, if the pressure is constant, for constant pressure, work done is equal to P times change in V. This is equal to pressure is 2 times 10 to the power of 5 Pascal, Newton per square meter, into 7.1 minus 6.3 cubic meter. This is equal to 2 times 7.1 minus 6.3, 0.8 times 10 to the power of 5 meter square goes with meter square, and we have left with 1 meter. Newton meter is joule. This is equal to 2 times 0.8 is 1.6 times 10 to the power of 5 joule. This is work done by the gas. From first law of thermodynamics, change in internal energy is equal to delta Q minus delta W. From sign convention, if work is done by the system or if there is expansion work, delta W is positive. If work is done on the system or compression work, delta W is negative. This is equal to delta Q is this one, 1.5 times 10 to the power of 5 joule minus, in this case, this work done is expansion work. Since this work done is expansion work, from sign convention, it remains positive, 1.6 times 10 to the power of 5 joule. This is equal to 1.5 minus 1.6 is minus 0.1 times 10 to the power of 5 joule. This is equal to minus 1 times 10 to the power of 4 joule. This is the change in internal energy of the gas. In this case, the change in internal energy is negative. Change in internal energy is negative. Why negative? Because there is a decrease in temperature of the system. This shows that the temperature gets decreased and decreased. The sixth exercise, a 2 kg object attached to a spring vibrates with a period of 0.5 pi second and amplitude of 0.4 meter. What is the magnitude of the maximum acceleration? Given m is equal to 2 kg attached to a spring vibrates with a period is equal to 0.5 pi second and amplitude is equal to 0.4 meter. This is x is equal to 0 and this is x is equal to a, and this block oscillates back and forth or to and fro about the equilibrium position with amplitude 0.4 meter. Therefore, what is the magnitude of the maximum acceleration? From period of simple harmonic motion, period is equal to 2 pi the square root of m over k. Period is 0.5 pi second. This is equal to 2 pi times the square root of m over k. Pi goes with pi. Dividing both sides by 2. 0.5 divided by 2 is equal to the square root of m over k. Squaring both sides 1 over 16 is equal to m over k, because this implies 0.5 is 1 over 2 is equal to the square root of m over k. 1 over 2 over 2 is 1 over 4. 1 over 4 square is 1 over 16 is equal to the square root of m over k is m over k. From this, k is equal to 16m. Multiplying both sides by k times 16. Here we have k, here we have 16m. Therefore, the force constant of the spring is 16 times m. Having this, from acceleration of simple harmonic motion at function of x is equal to simply the magnitude of the acceleration, actually k over m times x. If the position of the block is maximum, acceleration at the maximum amplitude is equal to k over m times a. K is 16 m divided by m times amplitude 0.4 meter. M goes with m is mass goes with mass. 16 times 0.4, 6.4 meter per second square. Therefore, the acceleration as a function of x is equal to amplitude is equal to 6.4 meters per second square, and this is maximum acceleration. Next, 100 meter runner starting from rest covers a 100 meter straight distance in 10 seconds. If we assume that he has been increasing his speed at constant rate, what is his acceleration? Given that the distance traveled by the runner is 100 meter and starts from rest, v0 is equal to 0. If the runner takes 10 seconds to cover this 100 meter, time is equal to 10 seconds. Find the acceleration of the runner, assuming that the runner increases its speed uniformly. From kinematics of particles, displacement is equal to v0 times t plus half at square. Displacement is 100 meter is equal to v0 is 0 because the runner starts from rest, 1 over 2 times acceleration times time is 10 square. 100 meters is equal to 1 over 2 times acceleration times 100. 100 goes with 100. Acceleration is equal to 2 meter per second square. The acceleration of the runner is 2 meter per second square. We can do this in different ways, or we have given displacement, initial velocity, and time. V average, by definition, the time rate of change of displacement or distance is equal to delta S is 100 meter divided by delta T is 10 second. 0 goes with 0. We have 10 meter per second. But for constant acceleration, V average is equal to V initial plus V final divided by 2. This is equal to V average is 10 meter per second. V initial is 0. This is 0. This implies V final is equal to multiplying both sides by 2, 20 meter per second. V final is 20 meter per second. V initial is 0. We have time. Acceleration is equal to V final minus V initial divided by time. V final is 20 meter per second minus V initial is 0 divided by time is 10 seconds. 20 minus 0, 20 divided by 10, 2 meter per second square. Therefore, the acceleration is 2 meter per second square. Exercise 8. 3 blocks of mass M1 is equal to 1 kilogram, M2 is equal to 2 kilogram, M3 is equal to 3 kilogram, placed on a horizontal frictionless table, are connected with string and pulled to the right by a force F is equal to 9 Newton as shown below. Find A, the acceleration of the system, and B, the tensions T1 and T2. To do this, the first case, by assuming the whole system as a unit, that is M prime, where M prime is equal to M1 plus M2 plus M3. The force is directly applied on this F. There are 3 forces acting on this system. One is normal force, the other is gravitational force, M prime times G. The third one is F. Normal force and gravitational force are balanced force. The only net force acting on the system is F. Therefore, net force is equal to M prime times acceleration. The acceleration of the system can be obtained from this. This implies A is equal to F, the net force acting on M prime is F divided by M prime. F is 9 Newton. M prime is M1 is 1 kilogram. M2 is 2 plus M3 is 3. 1 plus 2 plus 3 6 kilogram. Therefore, acceleration is equal to 9 divided by 6, 3/2 meter per second square. After finding the acceleration, now we can apply Newton's second law of motion for each system. For M1, we have T1, normal force N1, and gravitational force M1 G. The only net force acting on M1 is tension T1. Therefore, net force is equal to M1 times acceleration. The acceleration of the system is the same as the acceleration of M1 as well as the acceleration of M2 as well as the acceleration of M3. If the string is inextensible string, then the acceleration of the system remains the same. This implies the net force acting on M1 is T1. T1 is equal to M1 times A. This implies T1 is equal to M1 is 1 kilogram times acceleration is 3/2 meter per second square. This is equal to tension T1 is equal to 3/2 Newton. For M2, on M2 there are 4 forces. One is T2, the other is T1, N2, and M2G. N2 and M2G are balanced. N2 and M2G are balanced, but T2 minus T1 is the net force acting on M2. The net force acting on M2 is T2 minus T1 because the block is moving to the right. This is equal to M2 times A. And this implies tension T2 is equal to tension T1 plus M2 times A. Tension T1 is 3/2 Newton that we have already found, plus M2 is 2 kilogram times acceleration is 3/2 meter per second square. 2 goes with 2. This is equal to 3/2 plus 3 is 9/2 Newton. Tension T2 is 9/2 Newton. This is one option, by first finding the acceleration of the system and then apply dynamics of particles or Newton's second law of motion for each system to find the tension in the string. Or the second method, apply Newton's second law for each block. For M1, we have M1. On M1, we have T1, normal force N1, and M1G. Then net force is equal to M1 times A1. Let's write A1. But the net force acting on M1 is T1. T1 is equal to M1 times A1. This is our first equation. For M2, here we have T2, here we have T1. Tension T1 acts on M2 to the left, whereas tension T2 acts to the right. Normal force N2, downward force M2G. But the net force acting on M2 is tension T2 minus tension T1 is equal to M2 times A2. Therefore, T2 minus T1 is equal to M2 A2. This is our second equation. For M3, on M3 we have F and T2 to the left. Normal force N3 is upward, M3G is downward. The net force acting on M3 is F minus tension T2 is equal to M3 times A3. Therefore, F minus T2 is equal to M3 times A3. Since the string does not stretch, the acceleration a1, a2, and a3 are the same. Since the string does not stretch, the acceleration a1 is equal to a2 is equal to a3 is equal to simply a. Therefore, from 1, 2, and 3, we have T1 is equal to M1A, T2 minus T1 is equal to M2A, F minus T2 is equal to M3A. Let's add these three terms. When we add these three terms, T1 goes with minus T1, T2 goes with minus T2. On the left side, we have F. This is equal to M1 plus M2 plus M3 times A. A is common. A into M1 plus M2 plus M3. And from this, A is equal to F divided by M1 plus M2 plus M3. F is 9 Newton divided by M1 1 kilogram plus M2 2 kilogram plus M3 3 kilogram is equal to 9 Newton divided by 6 kilogram is 3 over 2 meter per second square. Newton per kilogram is meter per second square. And this is the acceleration of the system that we have already found in the first case. After finding the acceleration, substitute this into the first equation, in the second equation, and third equation to determine T1 and T2. To find T1, let's substitute this equation into the first equation. From the first equation, we have tension T1 is equal to M1 times A is equal to M1 is 1 kilogram times A is 3 over 2 meter per second square is equal to 3 over 2 Newton. This is T1. From 2, tension T2 minus tension T1 is equal to M2 times acceleration. Tension T2 is equal to, taking this to the right, T1 plus M2 times acceleration. Tension T1 is 3 over 2 Newton plus M2 is 2 kilogram times acceleration is 3 over 2 meter per second square. 2 goes with 2. Kilogram meter per second square is Newton. 3 times 2, 6 plus 3, 9 over 2. 9 over 2 Newton, tension T2. Or F minus tension T2 is equal to M3 times acceleration to find T2 actually. Taking T2 to the right and bringing this to the left, tension T2 is equal to F minus M3 times acceleration. Tension T2 is equal to F is 9 Newton minus M3 is 3 kilogram times acceleration is 3 over 2 meter per second square. 3 times 3, 9 over 2. 9 Newton minus 9 over 2 Newton is equal to 9 over 2 Newton, tension T2. Therefore, the acceleration of the system is 3 over 2 meter per second square, whereas the tensions T1 and T2 are 3 over 2 Newton and 9 over 2 Newtons respectively. The next exercise. At what distance from the equilibrium position is the kinetic energy 3/4 of the total energy in simple harmonic motion of amplitude 4 centimeter? Given that the kinetic energy is 3/4 of the total energy, either maximum elastic potential energy or 3/4 of maximum kinetic energy. Amplitude is given 4 centimeter and we are asked to find x. This is x is equal to 0 and this is x is equal to a, and this is a point between the lowest point or the equilibrium point and the maximum point. And let's assume this is A, this is B, and this is C. This distance is X, this distance is A. Therefore, mechanical energy at point B is the same as mechanical energy at point C is equal to mechanical energy at point A. Mechanical energy at A is equal to mechanical energy at B is equal to mechanical energy at C. Let's consider these two. Mechanical energy at B is equal to mechanical energy at C. When we say mechanical energy at point B, we have kinetic energy at point B plus elastic potential energy at point B is equal to mechanical energy at point C is simply kinetic energy at point C plus elastic potential energy at point C. But at point C the speed is 0, hence kinetic energy is 0 and elastic potential energy is maximum. At point B we have both kinetic energy and elastic potential energy. Therefore, kinetic energy at point B plus elastic potential energy at point B is equal to maximum elastic potential energy at C. But given that the kinetic energy is 3/4 of the maximum potential energy, that is 3/4 of maximum elastic potential energy plus elastic potential energy at point B is equal to maximum elastic potential energy at point C. Taking this to the right, elastic potential energy at point B is equal to maximum elastic potential energy minus 3/4 of maximum elastic potential energy. Maximum elastic potential energy minus 3/4 of elastic potential energy is 1/4 maximum elastic potential energy. But elastic potential energy at point B is half times k times x squared. This is equal to 1/4 times maximum elastic potential energy is half times k a squared. Half k goes with half k. X squared is equal to 1/4 a squared. Taking the square root of both sides, x is equal to a over 2. This is equal to a is 4 centimeter. 4 centimeter divided by 2 is equal to 2 centimeter. Therefore, x is equal to 2 centimeter. At x is equal to 2 centimeter, the kinetic energy is 3/4 of the total energy. A 0.2 kilogram body is in simple harmonic motion with a period of 0.05 pi second and amplitude of 0.01 meter. What maximum force acts on the body? Given that mass is equal to 0.2 kilogram and period of oscillation 0.05 pi second and amplitude is equal to 0.01 meter. What is the maximum acceleration? A maximum. This is the equilibrium position, x is equal to 0, and this is the maximum point of oscillation, x is equal to a. The acceleration is maximum when the block attains its maximum point of oscillation. At the equilibrium position, the speed is maximum, whereas the acceleration is 0. But the acceleration is maximum when the block reaches the highest point of oscillation. But to find the maximum acceleration of the block, we start from the period of simple harmonic motion. From period of simple harmonic motion, period is equal to 2 pi the square root of m over k. Period is given 0.05 pi is equal to 2 pi the square root of m over k. Pi goes with pi. 0.05 divided by 2. 0.05 divided by 2 is equal to the square root of m over k. 0.05 divided by 2 is 5 over 200, which is equal to 1 over 40 is equal to the square root of m over k. Squaring both sides, 1 over 1600 is equal to m over k. Multiplying both sides by k times 1600 K is equal to 1600 m, where m is mass of the block. From dynamics of particles, the restoring force is equal to mass times acceleration. Restoring force is equal to mass times acceleration, but the restoring force is k times x, which is equal to mass times acceleration, and acceleration is equal to k over m times x. The acceleration is maximum when x is equal to a. This is equal to k over m times a. This is equal to k is 1600 m divided by m times amplitude is 0.01 meter. M goes with m. 1600 times 0.01 is 16 meter per second square. This is the maximum acceleration. Since the restoring force is mass times acceleration, maximum inelastic restoring force is equal to mass times maximum acceleration. This is equal to m is 0.2 times acceleration is 16 meter per second square. This is equal to 0.2 times 16 is 3.2 Newton. This is all about today. Next time I'll be here with a new topic. Until then, have a nice time.